So system designed applications. So what are the system designed applications? So design of analog systems. Then we have to consider system specifications, power budget, and also bandwidth budget. And the design of digital systems, we have to take the system specifications, rise time budget, power budget, and the receiver sensitivity. And then for the design of digital systems, we have to consider the system specifications, rise time budget, power budget, and receiver sensitivity. Design of analog systems. These system specifications mainly consist of power budget, system specifications, and bandwidth budget. The design of digital systems also consists of system specifications, rise time budget, power budget, and also receiver sensitivity. The point to point links. A point to point link has a transmitter on one end and receiver on the other end. The three major optical link building blocks are transmitter, receiver, and the optical fiber. So the simplex point-to-point link consists of information source, optical transmitter, optical fiber, optical receiver, and the user. Okay. So transmitter to receiver, we are establishing the channel known as optical fiber. This is the simplex point-to-point link. So the performance and cost constraints are very important factors in OFC links. It is necessary to carefully choose the components to ensure that the desired design performance level can be maintained over expected system lifetime. So these point to point links can also contains analyzing a link, how to the system requirements are needed in analyzing a link or to establishing a link, desired transmission distance, data rate or channel bandwidth, the bit rate, the bit error rate. And also to fulfill these requirements, the receiver has a choice to choose the following components and their associated characteristics: multi-mode or single-mode optical fiber. So for multi-mode or single-mode optical fiber, the following constants should be taken into account, that are core size, B, core refractive index patterns. So next third one bandwidth, and fourth one attenuation, and fifth one numerical aperture. So these LED or laser diode optical source, emission wavelength, what are the LED or laser diode optical sources? Here emission wavelength, spectral line width, output pattern, effective radiating area, and also the emission pattern. So what are the pin or APDs? So how the pin or APDs can be operated? Operating wavelength, what are the sources they can depend? So operating wavelength, responsivity, speed, sensitivity. Okay. And also the point to point links. Two analyzers ensure the system performance. They are the link power budget, and the second one is system rise time budget. System considerations. First, it is necessary to decide at which the wavelength to transmit and choose the components according to that wavelength. If short distance, then we have to choose 800 to 900 nanometers. If long distance, then choose 1300 to 1500 nanometers. After choosing wavelength, it is necessary to choose three major building blocks: receiver, transmitter, and fiber. Okay. So after choosing wavelengths, you have to choose three building blocks, that is the optical fiber, receiver, and the transmitter. What are the system considerations? What are the system considerations? The photo detector may be chosen based on optical source, how much data can be transmitted over a particular fiber before amplifier is needed, and C, minimum optical power thus that must fall on photo detector to satisfy bit error rate. Okay, PIM. pin, simple, more stable, less expensive. Biasing voltage is required is 5 volts APD, avalanche photo detectors. So bias voltage required is 40 volts, but it has increased sensitivity than PIN. Okay.